Good morning, girls. Previous class we done the preparation, physical properties and chemical properties ammonia. Today is the oxides of nitrogen. We know nitrogen is having many oxides. Nitrogen is forming many oxides, and the oxidation number of nitrogen in that oxides is varies from +1 to +5. Okay. So here name, formula, oxidation state of nitrogen, common methods of preparation, physical appearance and chemical nature. Okay, it is given. So first we are taking dinitrogen oxide. It is also known as nitrogen 1 oxide because the oxidation state of nitrogen is 1 in this. All of you know how to calculate the oxidation number. Once last year we done in chapter. Okay, we done. But once again I will tell you here 2 nitrogen. So 2x we can write. 2x plus 1 oxygen is having -2. So 2x plus -2 equal to 0. So 2x equal to 2 and x equal to by 2 equal to 1. Okay. And the methods of preparation, it is coming in detail. It is prepared by heating ammonium nitrate. Okay. Then it is a colorless gas, neutral molecule. Okay. Next is nitrogen monoxide. Oxidation state is +2. NO formula. Then it's prepared by the reaction treating sodium nitrite with ferrous sulfate, sulfuric acid gives ferric sulfate plus NHSO4 plus water plus NO. It is a colorless gas and neutral molecule. Next is dinitrogen trioxide. N2O3, oxidation rate of nitrogen is +3 and it is prepared by reaction between NO and N2O4. Okay, it is a blue solid and acidic. Next is nitrogen dioxide, NO2 +4. It is prepared from lead nitrate. It is a brown gas and it is acidic. Then dinitrogen tetroxide, N2O4. What is the oxidation state? +4 and it is prepared by dimerization of NO2. Means two NO2 molecules combined together we will get N2O4. It is a colorless solid, liquid and acidic. Okay. Last one is dinitrogen pentoxide. It formula is N2O5. Oxidation state of nitrogen is +5 and it is prepared by treating nitric acid with phosphorus pentoxide. Was P4O10. Actually, it is P2O5. P4O10 is the dimer of P2O5. So that is why it is also known as phosphorus pentoxide. Detailed explanation is coming. It is a colorless solid and it is acidic. So this is no need of by hearting all these things. Okay. Next is resonance structure of oxides of nitrogen. We know resonance structure, how we can write. One compound can exhibit more than one structure. Okay. So here it is given N2O. So we know nitrogen. Here if you are I will explain. Okay, here nitrogen. We know nitrogen is having the atomic number 7. So we can write the electronic configuration as 2,5. So 5 is the valence electrons present in nitrogen, and for oxygen atomic number is 8. So 2, 6 we can write. So the 6 is the valence electron present in oxygen. Okay. So if you are considering this nitrogen, we know this nitrogen is having 5 electrons and oxygen is having 6 valence electrons. Okay. So this nitrogen is having 5 valence electrons. In that 2 valence electrons is used here for this bond formation. And this is having 6. In that 6, 2 is used here. So one bond is formed here from oxygen and one bond is formed from here nitrogen. So double bond is formed. And here if you are coming to this side, okay, then nitrogen again having 3 electrons. In that 2 electron is shared here. Okay, then one bond is formed. Okay, and one more electron is here. It is shared by 1 electron here from this nitrogen, and here 4 electrons is already it is there as lone pair. Only 1 electron is utilized for the formation of this bond. So 1 electron from this nitrogen and 1 electron from this nitrogen form this bond. So we will get a double bond. Okay. Then resonance means what will happen? Just a shifting of the electrons and pi bonds will happen. So from here 1 electron will be shifted to here. So 2 electron pair it is converted to 1 lone pair. Then here double bond will be converted to triple bond. How it is? Because these electrons are shifted to here. Okay. Then this automatically what will happen to balance the valency, this bond will be shifted to this oxygen. So this here double bond will be converted to single bond and that bonded electron is here. Okay, so it was 4, it is become 6 now. Okay, same thing here. If you are checking, and the shape of N2O is linear and the bond length is 113 picometer here, this side nitrogen NN bond length, and this is 119 picometer. Okay, so same thing, the explanation you can check for all things. Okay, no need of by hearting this one. If anyone want to get full marks on, you have to learn it, and you can check all the resonance structures. Okay, and you can ask me the doubt, because it is how much I am explaining also, you have to sit and draw the resonance structure. Okay, so that is about the resonance structures of oxides. Clear all of you? Next is preparation of various oxides of nitrogen. Just now we saw many oxides are there for nitrogen. So the preparation, how they are prepared. Okay. So many equations are there in this chapter. It is very difficult to by heart all the equations, reactions. At least what I am telling, that important reactions you have to learn. Okay. So first one is preparation of nitrous oxide. Nitrous oxide means it is which one? N2O. Okay. So N2O, how it is preparing means, it is prepared by heating ammonium nitrate. Ammonium nitrate means NH4NO3. It is prepared by heating ammonium nitrate. So ammonium nitrate on heating we will get nitrous oxide plus water. Okay. And very important thing is, nitrous oxide is also known as laughing gas. What is laughing gas? Nitrous oxide N2O. Okay. So next preparation is nitric oxide. Nitric oxide means NO. It is prepared from sodium nitrite. NaNO2. NO2 means it is ITE. ITE, nitrite. Okay. Is treated with ferrous sulfate and sulfuric acid. We will get ferric sulfate plus sodium hydrogen sulfate or sodium bisulfate plus water plus nitric oxide. Okay. So from sodium nitrite. Next one is preparation of N2O3. N2O3 is known as dinitrogen trioxide. 2 nitrogen and 3 oxygen. Dinitrogen trioxide. It is prepared by cooling equimolar mixture of NO and NO2. It is prepared by cooling equimolar mixture of NO and NO2 below 250 Kelvin. Okay. Next one is NO2, nitrogen dioxide, NO2. It is prepared by heating lead nitrate. NO3 means nitrate. Lead nitrate at 673 Kelvin. We will get lead oxide plus for NO2 plus oxygen. This NO2 in the resonance structure, you can see in that one electron, odd number of electron is there on nitrogen. So it is little bit unstable. So to convert that one into a stable compound, it will undergo dimerization. Dimerization means 2 molecules combined together. Okay, it will be undergo dimerization, and we will get a stable N2O4. We will get a stable N2O4. That is 2 molecule of NO2 undergo dimerization. We will get N2O4. It is a stable compound. So if you are checking below 615 Kelvin, below 6, it is double-headed arrow. Okay. See, this is heating and this is cooling. Okay. So below 615 Kelvin, the more amount of N2O4 will be there, but above 615 Kelvin. But below 250 Kelvin, NO2 will be more. Okay. So NO2 is which one? Unstable. It is unstable. So it is it will undergo dimerization and it will be converted to a stable N2O4. Okay. N2O4 means what? Dinitrogen trioxide, tetraoxide. It is that nitrogen dioxide. Here 2 nitrogen is there. That is why dinitrogen tetroxide for oxygen. Okay. The last one is N2O5. N2O5 means dinitrogen pentoxide. It is prepared by the dehydration. Dehydration means what? Removal of water from nitric acid. Dehydration of nitric acid HNO3 using phosphorus pentoxide. It is actually P2I5, P2O5, right? Phosphorus pentoxide. Its dimer is P4O10. Okay. So P4O10 also, or 10 also known as which one? Phosphorus pentoxide, because it is a dimer of P2O5. Okay. So N2O5, dinitrogen pentoxide, is prepared by the dehydration, means removal of water, dehydration of phosphorus pentoxide. Okay. So we will get N2O5 plus for HPO3. So that is about which one? The preparation of oxides of nitrogen. Next is oxo acids of nitrogen. Mainly nitrogen is having three oxo acid, HNO3 that is nitric acid, HNO2 nitrous acid, then H2N2O2 that is hyponitrous acids. Okay. So oxo acids means along with the hydrogen and nitrogen what will be there? Oxygen will be there. So that is why oxo acids. Okay, containing oxygen. So first we are moving to the preparation, laboratory preparation of nitric acid. In these three, nitric acid is important. Okay. So nitric acid is prepared by heating sodium nitrate and sulfuric acid. Okay. In a retort. Retort means it is like a round bottom flask, RB flask, and one condenser will be there. We have to heat, though the nitric acid vapors will be formed. That nitric acid vapors are cooled using water. We will get liquid nitric acid. Okay. So you have to know how in lab it is preparing. It is prepared by heating sodium nitrate and sulfuric acid. Okay. Then next is very important, Ostwald's process for the preparation of nitric acid, manufacture of nitric acid. It is compulsory question. We already discussed the manufacture of ammonia by Haber's process and its three favorable or optimum conditions for that reaction. Okay. So like that here, manufacture of nitric acid by Ostwald process, explanation, four steps are there, and what are the three favorable or optimum conditions. Okay, these questions you can ask, and all the steps, this is step 1, step 2, step 3 and step 4, the equation should be balanced, otherwise no mark. Okay, so first step is oxidation of ammonia to nitric oxide. First step is ammonia is oxidized to nitric oxide. So NH3, 4NH3 plus 5O2 in presence of platinum, RH means rhodium. Platinum, rhodium goes as catalyst. What is goes? Goes means it is a thin sheet. It may be made up of paper or anything. Here it is a thin sheet of platinum and rhodium with holes. Okay, that using as the catalyst. And the temperature is 500 Kelvin and the pressure is found to be 9 bar. So what are the three optimum conditions you can write? It is in the pressure is 9 bar and the temperature is 500 Kelvin and the catalyst platinum, rhodium goes. These are the three conditions. First the catalyst and which one, temperature and the pressure. These are the three favorable and three optimum conditions for the manufacture of nitric acid. So we will get NO plus water. Second step, oxidation of NO to NO, nitric oxide to NO2. So nitric oxide is treated with oxidation. It will undergo oxidation with the atmospheric oxygen below 100 degrees Celsius. It will be converted to NO2, that is nitrogen dioxide. Next is the formation of nitric acid. This nitrogen dioxide is absorbed by water. It will be converted to nitric acid plus NO. Why it is AQ? Because water content is there. So we got nitric acid, aqueous solution of nitric acid here. Then fourth step is concentrating nitric acid or concentration of nitric acid. We got the nitric acid here, but that nitric acid is containing water. So how we can do the concentration? So first we have to concentrate by distillation. We know distillation, it is a method for purification. Last year it was there. So first concentration is done by distillation. So we will get a azeotropic mixture containing 68.5% of nitric acid. What is an azeotropic mixture means? That mixture, it boils without change its composition. Okay. For example, here we are getting an azeotropic mixture of 68.5% nitric acid and the remaining thing will be water, that is 22.5% will be what? Water. Okay. Yeah. So 68.5% nitric acid and the remaining water will be there in that mixture. But if you are boiling that mixture, the composition will not change. Okay. So azeotropic mixture we will discuss detail in solution chapter. Right. So now concentration, first concentration is done by distillation. So we will get 68.5% of nitric acid. Remaining water will be there. Then further concentration we can done by treating with concentrated sulfuric acid. Okay, so we will get 98% of concentrated nitric acid. Okay, then last, anhydrous nitric acid is obtained by treating P2O5, means what, phosphorus pentoxide. This can write as P4O10 also, because it is P4O10 means it is a dimer of P2O5. Dimer means two molecules of P2O5 combined together. We will get P4O10. Okay, so anhydrous nitric acid is obtained by which one? By treating with phosphorus pentoxide. Okay, so concentration means what? First we have to do this distillation, then 68.5% of nitric acid we will get. Then again concentrated by using concentration by concentrated sulfuric acid. So we will get 98% of nitric acid, concentrated nitric acid. Then anhydrous nitric acid is obtained by treating with which one? Phosphorus pentoxide. So preparation of ammonia, preparation of nitric acid. It is once again Ostwald's process. It is containing 4 steps, very important. Okay, so first step, oxidation of ammonia to NO. And what are the optimum conditions? Platinum, rhodium goes catalyst, 500 Kelvin temperature and 9 bar pressure. Then second step, oxidation of NO to NO2. Then formation of HNO3, then concentrating HNO3. Okay, so that is about which one? The oxo acids and their preparation of nitrogen. Oxo acids and their preparation. Next is the physical properties of nitric acid. We know we are using nitric acid in lab, right? Nitric acid is colorless, pungent smell. But you can see some color change in our lamp, because it is due to the formation of N2O, dissolved oxygen. N2O, nitric acid will be converted to which one? N2O, that is its oxide. It will be converted to N2O. So because of that dissolved which one, N2O, it is having which one? A brown color or yellow color may be developed. Usually nitric acid is which one? It is colorless and pungent odor. And it is soluble, highly soluble in water. And lab, the concentration of the nitric acid we are using 68% by mass. 68% is nitric acid and remaining water will be there. And the specific gravity equal to 1.504 gram per milliliter. And the boiling point is 355.6 Kelvin. Freezing point is 231.4 Kelvin. These points it is not at all no need of by heart. Just you have to know this is the physical properties. Okay. Then in this physical properties, one important part is it is corrosive. Okay. Nitric acid we know it is concentrated and it is corrosive. Okay. If it is on the skin, it will produce. If it is on the skin, it will form yellow blisters. Yellow color blisters it is formed due to the formation of xanthoprotic acid. It will react with the skin and it will be converted into the skin and it form a compound that is known as xanthoprotic acid. So you can expect 1 mark question that when a nitric acid on the skin, yellow blisters are developed. It is due to the formation of which chemical? It is due to the formation of, not chemical, it is due to the formation of a compound that is xanthoprotic acid. Okay. So that is the physical properties. Next we are moving to the chemical properties. Chemical properties means first one is the acidity of nitric acid. We know nitric acid is an acid. Okay. So nitric acid will dissolve in water. It will be converted to NO3 minus and H3O plus. H3O plus means what? It is H plus, this one nitric acid, hydrogen, and it will combine with water. We will get H3O plus. Okay. So any solution that is containing H plus or H3O plus is strong acidic. We know that. Okay. The next chemical property is oxidation property of nitric acid. It is a strong oxidizing agent and it will react with most of the metals except gold, platinum, etc. It will convert that metals into corresponding nitrate and it will be reduced to which one? We know oxidizing agents means what? It will oxidize others, but it will be itself it will undergo reduction. So nitric acid oxidize the metals to their metal nitrates and it will reduce to N2O, NO, etc. depending upon the which concentrated or dilute nitric acid is using. So generally we can say it is a strong oxidizing agent. It will oxidize the metal to their metal nitrates. Okay. For example, it is given when it is react with zinc. Dilute nitric acid is treated with zinc. It will be converted to nitrate. Metal will be converted to its nitrate and it will be reduced to which one? N2O. Okay. Then second, then with concentrated nitric acid, same zinc. This product is same, but only the difference is which one? NO2. This is dinitrogen oxide and this is which one? Nitrogen dioxide. You can expect this type of questions. Okay. Then with copper, concentrated dilute nitric acid, it is forming copper nitrate plus NO. All other products are same. Then with concentrated nitric acid, it is forming same product, but here it is different. Okay. So generally it will oxidize the metal into their nitrate and it will be reduced to N2O, NO or NO2 depending upon concentrated or dilute nitric acid if you are using. Okay. Then some metals like chromium and aluminium. Which one? Chromium and aluminium. It do not dissolve in which one? Our nitric acid, because this chromium and aluminium form a passive metal oxide on its surface. That means if this is aluminium and chromium, it will form a metal oxide coating on its surface. Okay. So that is why it cannot dissolve or it cannot be attacked by, this metal cannot be attacked by nitric acid. Okay. And that is known as the passivity of a metal. Okay. So some metals like chromium and aluminium, it do not dissolve in nitric acid because these metals form their metal oxides on the surface. Okay. So it cannot be attacked or dissolved. It cannot dissolve in nitric acid. And this ability of metals are known as what? Passivity of metals. Okay. So that is the physical properties, and which one? In chemical properties, the oxidation properties of property of nitrogen. Okay. Next is the reaction with non-metals. Nitric acid react with non-metals like iodine, carbon, sulfur, phosphorus, etc. They convert them into corresponding acids. Okay. So iodine react with nitric acid, concentrated nitric acid, not dilute. Okay. So iodine react with the concentrated nitric acid, iodic acid is produced. That means iodine is converted to its acid. Okay. Then carbon react with the concentrated nitric acid, we will get carbon dioxide. Carbon dioxide is an acidic substance. That means it dissolve in water, we will get carbonic acid. Then third, sulfur. Sulfur react with concentrated nitric acid, it will be converted to sulfuric acid. Then phosphorus. Phosphorus is converted to H3PO4. H3PO4 means what? Phosphoric acid. So generally when non-metals react with concentrated nitric acid, corresponding acids are produced. Clear? Then next is brown ring test. We know what is brown ring test. We are doing this test in lab for the detection of nitrate. Okay. So how we are doing the test? All of you know that what we are doing. Concentrated sulfuric acid is mixed with our which one? Salt solution. Then freshly prepared ferrous sulfate solution we have to add through the side of the test tube. Then we will get a brown ring in between the junction of two liquids. Okay. So salt solution plus concentrated sulfuric acid. Then in a one test tube, then add freshly prepared ferrous sulfate solution through the side of the test tube. Then we will get a brown ring at the middle of the junction of the two liquids. Okay, that is why it is known as a brown ring test. So how the brown ring is formed in the middle or in the junction of the two liquids is, we know nitrate. It is the main reaction involved in this brown ring test is nitrate. Generally in our lab, which nitrate we are taking? Strontium nitrate. Okay, plus Fe2 plus. Fe2 plus is from our ferrous sulfate solution. Then H plus is from our sulfuric acid. With sulfuric acid, concentrated sulfuric acid. Then we will get Fe3 plus plus NO plus water. Okay. In next step, this Fe3 plus NO and water will react with together. We will get H2O6 plus 2 plus, this is a complex. It will combine with NO. That means these first step reactants react together. We will get a complex. that is nitrosyl complex because it is containing NO group. Okay, so form a nitrosyl complex. So the brown ring is due to the formation of which one? Nitrosyl complex. Okay, so that is brown ring test. We know two types, two way we can do. Okay, we can mix the salt solution plus concentrated sulfuric acid in one test tube, then freshly prepared ferrous sulfate solution through the side of the test tube. Or you can mix the salt solution with the ferrous sulfate solution, then you can add what? Concentrated sulfuric acid through the side of the test tube. Okay. Next is the structure of nitric acid. Nitric acid is a monobasic acid. Monobasic acid means it is containing only one hydrogen, HNO3. It is containing only one hydrogen and it is having a planar shape. That is, in one plane it is having a shape. Okay. And hydrogen, oxygen. Here it is nitrogen, oxygen, oxygen. So HNO3. And the bond, this is 96 picometer bond length. This bond angle is 102 degree. This bond length is 140.6 picometer and this bond angle is 130 degree. Oxygen 121 picometer. Okay, so that is which one? The structure of nitric acid. So this is about today's topic, girls. Thank you so much.